Hello guys, today we're going to be solving move zeros. Let's go ahead and solve this question. Alright, so we're given an integer array numbers. We have to move all the zeros to the end of it while maintaining the relative order of non-zero elements. Okay, we must do this in place without making a copy of array. I think initially what I'm thinking is that because we have to move these zeros to the end of the array, you could probably have something like maybe like 2 pointers, something like, okay, like 0, 1, 0, 3, 12. We could have a pointer at the beginning and one at the end. Basically, if you see a 0 right here, you go ahead and just swap it. So that 12 would go right here, 0 would go here. We'd see a 1 and we'd see a 3. We'd go ahead and skip these. Or actually, we could go ahead and just increment it because we want that left pointer hit at 0. And for this one, you could see a 0 and you see that 3. So it'd be comma 1, comma 3, and then comma 0. But you see how this is, let's see. We want to keep the relative order of the non-zero elements. So this actually would not work, but I'm just saying that was my initial reaction. That's what I thought. Instead, we could have an algorithm with, instead of having 2 pointers at the end, we could just have them at the beginning. So for example, it would be 0, 1, 0, 3, and 12, right? So we could have 1 pointer at 0 and 1 at 1. So this left pointer will always point to a non-zero or a 0 element, right? And then the right pointer would point to a 1, points to 1, to non-zero. So 1. Okay, let's go ahead and have that then. And we go ahead and just swap it. So we could say 1 is here, now 0 is here. And we go ahead and just increment it. So now we have 0 with 0. And this, since this right pointer is not pointing at a non-zero, we just have increment it, so it hits 3. So now it points 3, and we go ahead and swap these. So you get 1, comma 3, comma 0, comma 0. And we have one last one, which is 12. And we just go ahead and swap it one last time to get 1, 3, 12, 0, 0. Yeah, okay, let's go ahead and write this algorithm down. So let's go write the question down. Say 0, comma 1, comma 0, comma 3, comma 12. So our pointer would be at 0, and 1 is at 1. Okay. Okay, let's go ahead and write this algorithm down. Okay, so I would say left pointer will be equal to 0, and then we could say while, or actually for right pointer in range length of nums, we could run this algorithm which says, go fix this test case. Okay, so right pointer will keep on going to the right if right pointer is not equal to 1 or not equal to 0. Alright, but we actually do nums. Then we could go ahead and run the swap. So let's go ahead and swap. So let's say swap would we use a bucket nums of left pointer. Oop. I could say left pointer is, oh actually, nums of left pointer is equal to nums of right pointer. Actually, let me go back to this. So we're saying that left pointer must equal to 0. I feel like this is not really true. I guess this is not really a good example. Let's go to a different example. Let's do 1, comma 2, comma 0, comma 3, comma 4, comma 0, comma 7, comma 9. Okay. So our left pointer will start at a non-zero. We want to swap that with 3. So that'd be 1, comma 2, comma 3, comma 0, comma 4. I guess we just keep on swapping them. That means we'd have to swap. As soon as we see a 0, we'd have to swap them many times. Otherwise, we'd have another algorithm. Let's try pushing this out. I think there could be another algorithm where we have, oops. Okay, I'll use green then. Okay, well, we have one algorithm at 1. And we have another one at 1. So these could, left and right could be the same. We swap with each other. Increment left. Okay, swap with itself. Ignore this. So left pointer would be here. We could swap this. So we could swap this. 3 and then 0. And 0. New pointer would be right here. 4. We swap them again, we get 3, 4, 0. And there's a pointer at 0 right here. We skip that with 7. So it'd be 7, 0, 0. Then 9. Okay. Okay, we could say, now we could say the left, the nums of right pointer is going to be equal to bucket. I think this could work. We just return. We don't even return anything. Yeah, okay. Okay. Ah, I forgot. Left pointer. Let's see. After we do the swap, we go ahead and increment. If the swap never happens, should we increment? Not really. Okay. Okay, this works. I think we could actually maybe make this more efficient. Left pointer is at 0, but we could kind of increment left pointer. Let's see. Left pointer, well, left pointer is not equal to 0. Left pointer plus equals 1. Right, so it'll equal 0 at one point, But let's say there was never a 0. Alright, if there is never a 0 in this, is less than length of nums. Okay. Now I say in range starting from this ends at that. I think this might actually be a bit quicker. For some cases, yes. Right, that might be a bit quicker. See if it works. I think we could do this. This is kind of like my original. Oop. Index is, well, left pointer is not equal to 1, and left pointer is less than or equal to. How's this out of range? Nums left pointer is not equal to 0. Because you want it to be equal to 0. Maybe plus equal 1. Well, left pointers are at 0. That's what I'm saying, bro. How's that? It should not fail, right? Alright, I'm gonna have to check this one. We gotta reverse it. This would work. Yeah, there you go. Oops. Okay. I'm so confused. What is going on? Yeah, this version is not that good, right? Let's say if there was... This is the optimized version, right? If numbers right is not equal to 0. If numbers is not equal to right. Yeah, right. That's what I'm thinking. I want to optimize this, right? Because we have 0, comma 1, comma... Actually, let's go back to this version. So this would be 1, comma 2, comma 0, comma 3, 4, 0, 7, 9. Right, so we have this original version, right? The original one was saying swap 1 with 1 because we wanted to keep on swapping. As soon as you hit this, right, so 1 with 1, you swap it with itself. 2 with 2, you swap it with itself. 0, you skip this one. 3, this is where it happens. Okay, so 1, you swap it with itself. Increment 2, you swap it with itself. Increment 0, you skip this one. 3, you swap with 0. Right, so 3, you swap with 0. And you see, you increment back to the right, you see 0, you skip that. Right, so my version, I'm trying to think of a way where we could just go ahead and skip. So we have 1, 2, 0, 3, 4, 0, 7, 9. Right, with this version, we'll just find this first 0. Then we'll start swapping with the 3. Yeah, so we just skip it all. Okay, let's try to do that actually. I want to try to solve it like that. Right, because we did that for once, but we didn't do it for all, right? And also, this would also be bad because if there's no zeros, we ran one whole entire extra loop, which is O then. So let's go ahead and restart this. Let's see what they recommended. So we could say left pointer is equal to 0. We could say for right pointer in range length of nums. We go ahead check right pointer. If right pointer is not equal to 0, then we go ahead and swap it with the left pointer. If left pointer is not equal to right pointer, then we do the swap. Because we don't want to swap it with itself, right? Then we perform the swap. But we should still increment. That's what I'm thinking. When do we increment? If left is not equal to right, then you go ahead and swap. Yeah, okay. I think I get it. I think for this, it doesn't really matter much. Yeah, alright, it shouldn't really matter much. We perform the swap, so we get to say bucket is equal to left pointer nums left pointer is going to be equal to nums right pointer and nums right pointer is going to be equal to bucket. Then it doesn't really matter what happens. We want to increment left pointer, so left pointer plus equals 1. So if they're not equal, we go ahead and if they're not equal, we go ahead and do the swap. If they are equal to each other, then we just add 1 and we skip it. Yeah, this should be good. Only thing that might be wrong is this right here, but in our case, it should be fine, I think. Let's see. Yeah. And yeah, we got it. It's a really nice way of thinking it. So guys, that's how you solve move zeros. And this is, okay, can I minimize the total operations done? I think that's what this follow-up is. Does that, let's see, let's go see if there's actually a better way of solving this. Oh shit, I was on the wrong. I sent it to the wrong GPT. What is this? Okay, whoops. Wait, what is this? Okay, what is this one saying? Oop. Oh shit. Okay. right zero fill. Okay. If numbers in this right position is not equal to 0, I thought this was what we did. Alright, whatever. Think I had enough of this question, but see you guys later.